Hello, and welcome to alcohols and benzene. Types of alcohols and benzene. We're going to briefly mention benzene. You do need to know a little bit about some of the types of alcohols, so we'll mainly focus on that. Alcohols contain that hydroxy functional group is their functional group. This can be anywhere in the molecule, and again, that's that OH group. What makes this hydroxyl group instead of just a regular hydroxy, like we talked about in acid base, is that there's going to be carbons or a carbon chain bonded here, so dissociation will not occur, and therefore, as we talked about before, alcohols are non-electrolytes. So this OH group does not break off and have basic behavior. There are different types of alcohols. The first ones are what we call the monohydroxy alcohols. Monohydroxy alcohols are called mono because they only have one hydroxy group. So alcohols with one hydroxy group can be classified one of three ways. We have what we call the primary alcohols. Primary alcohols, you identify where the OH is, look at the carbon it's attached to. That carbon is attached to one other carbon. So therefore, that's a primary alcohol. So this would just be called 1-propanol. So the naming is pretty much just what you'd see on the periodic table, nothing special there. We can categorize the next one as a secondary alcohol. And this does actually affect the properties that the alcohol has. So the carbon that the hydroxyl group is attached to two other carbons, thus making this a secondary alcohol. And this would be called 2-propanol. So no real surprises there. A tertiary alcohol has a situation where this carbon that the OH is attached to 1, 2, 3 other carbons. Now, because this has that methyl group sticking off of it, we would have to name that first. So this is called 2-methyl 2-propanol. So still following those nice IUPAC rules, nothing crazy going on here. Again, these are all called monohydroxy alcohols, and they're named by just having that OL ending and a number to show where the OH grows. In the tertiary alcohol, we just had to also show that branch, which we stuck right out front like we would expect based on our other naming rules. We can have more than one hydroxy group. We could have a dihydroxy alcohol, so you'll notice 1, 2 hydroxys here. So these are named a little bit different. This would be called 1, 2, and then we actually just call the stem propane, and we actually make a second word, which is diol. You're not really generally responsible for naming these in terms of writing the name out, but you might have to recognize them in some sort of a paragraph on Part C on the Regents or something like that. So it's nice to have a little bit of familiarity. Our next example, a trihydroxy alcohol, 3 hydroxy groups, 1, 2, 3. So each carbon has a hydroxy on it. And then we just call that propane. And instead of diol, there's 3 of them. So this is triol. So some things to note in general when we're talking about the properties of water and hydrocarbons. Water, remember, super, super polar. A hydrocarbon, I'm going to go with the example of ethane, is completely nonpolar, very even sharing of electrons. A nice example of an alcohol is ethanol. The reason this is a nice example is because we know that ethanol dissolves in water. Rubbing alcohol is a mixture of ethanol and water. Things like drinking alcohol, which you clearly know nothing about, is a mixture of alcohol and water. This molecule, if you look at it, does have polarity. It's not symmetric. So this molecule actually has moderate polarity. It's basically like ethane with an OH stuck on it, and that OH does look a little bit like water. So what this actually does for us is gives us very strong intermolecular forces in water. We have very weak intermolecular forces in ethane. And we have medium or moderate intermolecular forces in ethanol. This leads to some of the physical properties that these compounds have, which include the fact that alcohol is water soluble Ethane is not. Now, another important physical property is we're going to have a very, very high boiling point for water and a very, very low boiling point for ethane. It would actually be a gas at room temperature, whereas alcohol falls right in the middle, or ethanol at least falls right in the middle, and has a medium boiling point. So those are some of the important physical properties. Excuse me. I apologize, I had to take a moment and open my window. I was overheating a little bit. What's nice to understand about this is the fact that that moderate structure that alcohols have, what I mean by moderate structure is they almost have a portion of their molecule that has that kind of like hydrocarbon nature to it, that looks like a hydrocarbon. Then they have a portion of their molecule that's not hydrocarbon-like, that gives them polarity, that gives them that ability to interact with water molecules, which gives them solubility in water that hydrocarbons just don't have. Generally, alcohols with up to 4 carbons are soluble in water. Once you get to larger alcohols, the properties of the carbon chain kind of take over and influence that. They make the molecule kind of a little bit more nonpolar and therefore less soluble in water. Denatured alcohol is ethanol that is used for a lot of lab purposes or as an antiseptic. We have, for our labs in here, denatured alcohol. It actually usually has a touch of methanol added to it, and very, very little methanol is extremely poisonous. So by adding that poison to the alcohol, it will hopefully prevent people from consuming it. I also want to talk for a minute about what's called the benzene ring. Benzene rings, when you look at them drawn in a structure, often look like this. So I don't care if you draw this whole thing out. Please don't feel like you need to. When you see these ring structures drawn in different formulas or different, chemical structures or formulas that you're looking at, very often the other way of showing this is like this. All of those are shorthand for a benzene ring. And a benzene ring is a 6-carbon ring that has three double bonds in it that are moving in what we call resonance. So this double bond isn't really always here. Sometimes the electrons kind of bounce over here a little bit. These are very, very mobile resonating electrons. One of the places that we talked about these before is in molecules that present with a lot of colors, like the anthocyanins. Those mobile electrons allow these molecules to reflect a lot of different energies of light, and therefore we see them as different colors. Benzene is found in crude oil. It's a very important petrochemical. Those rings occur a lot in nature. When they occur in natural molecules, they're not so problematic, but they can actually, if you're using just regular benzene as a solvent, because it does dissolve organic stuff because it's so nonpolar, it actually can have some cancer-causing properties. Benzene is very necessary for pharmaceutical production. If you look up some drug structures online, you'll see that they pretty much always have those benzene rings in them. So it is actually very important from petrochemicals that benzene rings are derived to be able to actually make certain pharmaceutical drugs. A lot of pharmaceutical drugs actually also derive their benzene rings from plant molecules as well. So depending on how it's handled, it can actually be perfectly safe to work with benzene, but you do have to be aware of its potential cancer-causing properties as well.